Let's look at summation depending on exponential series. Okay, concept is same. So let's directly jump in. So our first problem is cos theta sin theta plus cos square theta sin by 2 factorial plus cos cube theta sin 3 theta by 3 factorial and on and on and on. We shall treat this as what? We can treat it as a sine series because sine theta, sine 2 theta, sine 3 theta. So let's say S is equal to this. So in that case, the corresponding cosine series would be 1 plus cos theta plus cos 2 theta cos square theta by 2 factorial plus cos cube theta cos 3 theta by 3 factorial. Okay, so our C plus Si would be equal to, there is nothing corresponding to 1, so 1 plus, now these two will give us, cos theta is common, so cos theta plus I sin theta will give us e to the power of I theta plus cos square theta is common, so cos square theta, and we have cos 2 theta plus I sin 2 theta, so which can be written as e to the power of I 2 theta by 2 factorial plus cos cube theta, and now in this case e to the power of 3 I theta by 3 factorial plus on and on and on. Okay, now let's write it like this: cos theta e to the power of I theta plus cos theta times e to the power of I theta the whole square by 2 factorial plus cos theta times e to the power of I theta cube by 3 factorial plus on and on and on. Do you recognize this pattern? This is an exponential series. So we know the summation of this. It is going to be e cos theta times e to the power of I theta. Now this can be written as e to the power of cos theta, and e I theta can be written as cos theta plus I sin theta. Okay. Now let's multiply the exponent. So cos square theta plus I sin theta cos theta. Okay. E to the power of cos square theta, and this I sin theta cos theta can be written as what? Let's do one thing. Let's split it first. Log rules. I sin theta cos theta. Okay. E to the power of cos square theta times, now e to the power of I theta is what? Can be written as cos theta plus I sin theta. Right. So cos of sin theta cos theta plus I sin of sin theta cos theta. Okay. Now beyond this we can't really go. So remember, this is C plus IS, and what do we have to figure out? We have to figure out S. So here S is the imaginary part. So S would be equal to E cos square theta times the imaginary part, that is sine of sine theta cos theta. And if we want, we can further write it as sine of sine theta cos theta can be written as half of sine 2 theta. So this is our expression for that summation. Let's say we are given the problem 1 plus e to the power of sine alpha cos of cos alpha plus e to the power of 2 sin alpha cos of 2 cos alpha by 2 factorial plus e to the power of 3 sin alpha cos of 3 cos alpha and like that so on. Now this would be obviously the cosine series. So the corresponding sine series would be e to the power of sine alpha sine of cos alpha plus e to the power of sine alpha 2 sine alpha sine of 2 cos alpha by 2 factorial plus on and on and on. Okay, so c plus is would be equal to what? There is nothing corresponding to 1, so 1 plus e to the power of sine alpha is common to both. Now cos of cos alpha plus I sine of cos alpha would be e to the power of I cos alpha plus e to the power of 2 sine alpha and cos 2 alpha cos of 2 cos alpha plus I sine 2 cos of alpha will be e to the power of 2 I cos alpha plus on and on and on. And here we have a 2 factorial. Okay, now this we can write it as 1 plus e to the power of sine alpha plus I cos alpha plus e to the power of 2 is common, so 2 sine alpha plus I cos alpha by 2 factorial plus on and on and on. Okay, now what else can we do? This is basically a exponential series, right? I plus e to the power of 1 plus e to the power of e square by 2 factorial e cube by 3 factorial, like that it will go. So this we know how to do the summation. So e to the power of sine alpha plus I cos alpha, right? And now comes the tricky part. You have to be very careful with the position of the powers. Now e to the power of sine alpha times e to the power of I cos alpha. So addition has become multiplication power rules. Okay, so now what do we do? This e to the power of I cos alpha, we can write it as e to the power of sine alpha times e to the power of I theta is cos theta plus I sine theta. So theta here is cos alpha, so we can write it as cos of cos alpha plus I sine of cos alpha. And now we can multiply the exponents. So e to the power of sine alpha times cos of cos alpha plus e to the power of sine alpha times I sine of cos alpha, right? Okay, so this entire thing is the power of this e. Now e to the power of sine alpha times cos of cos alpha. Now again we can convert this addition to multiplication. So e to the power of I e sine alpha sine of cos alpha, right? Now again this we can treat it as a single unit. So e to the power of I theta is equal to cos theta plus I sine theta. So let's do that. So e to the power of sine alpha cos of cos alpha times this becomes cos of, let's put the bracket, cos of this entire expression. So this becomes e to the power of sine alpha sine of cos alpha plus I sine of e to the power of sine alpha times sine of cos alpha. Okay, and here we had to figure out the summation of C. So C is the real part. So C will be the e to the power of sine alpha cos of cos alpha times the real part. So cos of e to the power of sine alpha times sine of cos alpha. So this is the required expression for summing the given series. That's it. Bye.